So we will continue with these problems with JEE Mains for how to solve problems involving that comes in JEE Mains. So this is a problem like 5 kg block connected with a 5 kg the rope of length 2 meter, and this is a light string 3 kg. I need to find tensions at P, Q, everywhere. So let us say, let here the tension be T1. So here the tension will be T1. Now I take this 5 kg block, like to find out the tensile forces at Q, P and everywhere. And this is the 5 kg block, and this is the 5 kg rope of length 2 meter and connected with a light inextensible string holding a mass of 3 kg. I need to find out all the forces involved. So let us say I take this 5 kg block. On 5 kg block there are forces 5G sine 37, and here there is a tensile force T. Let us say 5 kg block is accelerating in this way. So I can write an equation 5G sine 37 minus T equals to 5A. Now I take this part of the string, this part. So here I say, here there was a tensile force T like this part, and I say, let us say this tensile force to be TQ. And this part of the string will have a mass, since 5 kg rope of the length of the rope is 2 meter and the mass is 5 kg. For 1 meter it will be 2.5. So I say here it is 2.5 G sine 37. So I write the equation acceleration like this: T plus 2.5 G sine 37 minus TQ is equal to 2.5 A. This is one equation. Now I take this part of the string. Here TQ will be like this. Here TP will be like this. And here again this mass will be 2.5 G sine 37. Acceleration in this way. So I can write this equation: TQ plus 2.5 G sine 37 minus TP is equal to 2.5 A. One equation. Now I take this string. Here it is TP. Let this be tensile force T1. Here it is T1. Here it will be T1. So this is T1. So I can write TP minus T1 is equal to 0 into A, because this string is massless. So here I write TP is equal to T1. We get an equation. Now for this 3 kg block, forces are T1 in this way, 3G is downward, acceleration upward. So I can write T1 minus 3G is equal to 3A. Solving this following equations, we can get the tensile force at different points. So this is another problem where you need to find out the tensile forces. So let us go with 5 kg block. Here it is T2. So since string is massless, so here it will be T2 only. Here it is T2. Here there will be, since it is T1, so here it will be T1. So here it will be T1. Now let us resolve all the forces. 5 kg, and I say, let us say 5 kg block is moving upward, I can say. So 200 is in this way, T2 is in this way, acceleration like this, 5G sine 37 in this way. So I can write 200 minus T2 minus 5G sine 37 is equal to 5A. Now I take 3 kg block, T2, and this is T1, acceleration in this way. So T2 minus T1 is equal to 3A. once again I can repeat, like all the blocks will have same acceleration, as in time t the displacement of each block is same, so the accelerations will be same. Now I take this 2 kg block, one is T1 acting in this way, T1 is acting in this way, 2g sine 37 is acting in this way, acceleration in this way. I can write T1 minus 2g sine 37 is equal to 2a. So solving this all three equations, you can easily find out the tensile force T1 and T2 as well as accelerations. So here we want to find out the normal reaction exerted by M2 on M3. We can solve individually, like this is M1, this is F, M2 will be giving a force, let that be N1, and M1 is accelerating in this way. So I can write F minus N1 is equal to M1 into A. I take this M2 block. Since M2 is exerting N1 force on M1, so M1 will also exert N1 force on, and M3 will be exerting can write in this way, and M3 on M3 the only force is N2, so I can write N2 is equal to M3 into A. You can easily solve these equations to find out the normal reaction, that is N2, or else you can have, since this M1, M2, M3 are accelerating with same accelerations, the only force acting on this combined system is F only. So I can write F is equal to M1 plus M2 plus M3 into A, or A is equal to and here on this M3 I can write directly N2 is equal to M3 into A, that is M3F divided by M1 plus M2 plus M3. You can easily find out by this way, or you can solve these equations to find out the common acceleration as well as the normal force. Now we will discuss about constraint theory. By explaining this, we can again proceed with the problems related to JEE Mains. Now this theory is used to find the relationship between, or relationship of velocities or accelerations of different objects connected through one string or through number of strings. This theory is used to find out the relationship of velocities or accelerations of different objects connected through one string or through a number of strings. Through one string, we have already discussed that displacements of all the blocks or all the objects will be same in time t, for which velocities or accelerations will be same. Now in this theory we have 2 points. Number 1 point, the length of the string remains same, that is inextensible string. And number 2, the string always remains taut. Taut means tight ordinarily. that is string never slacks. So the length of the string remains same, that is in inextensible string the string always remains taut, tight ordinarily, or the string never slacks or loose ordinarily. String never becomes loose or slack. Now let us give a simple example where we can have this constraint theory. Here I am teaching you this string constraint. That means another point we can have when the string becomes a taut. Let us take an example. Like if this is a string and there are two particles, particle P, particle Q, and the velocities are like this, V1, V2. Let this angle be theta 1, let this angle be theta 2. So here I can write for string to become taut, the relative velocities or relative accelerations of particles along the string should become 0. That means I will resolve the velocity of the particles along the string, V1 cos theta 1. So it is V2 cos theta 2. So here I can write V1 cos theta 1 minus V2 cos theta 2 should be equals to 0. Relative velocities of the particles along the string should always become 0. That is V1 cos theta 1 must be equals to V2 cos theta 2. Now I have another way of finding out the relationship. This was about number 2 point where the string always becomes tight, or the relative velocities of the particles along the string should always become 0. Now we will explain this point number 1 where we want to find out relationships of particles or objects connected through one string or through multiple string. Let us have an example. Let us say this is body 1, this is body 2, this is body 3. Now always take the display, and they are accelerating or something released from rest, so they are accelerating, and I am trying to explain at any instant. So always try to find out the or take the displacements of bodies from a fixed point. I can take the displacement from this point, but I prefer to take through this point, because at any instant of time this wrapped part of string on the pulley always remains same, whatever the condition may be. So I will not consider this wrapped part of the string that is wrapped on the pulley while taking the length of the string, because anyway this part is constant. So I take, let us say the displacement, this one be L1, or I will take x1, that will be very fine for me. I take this is x1, I take this is x3, and I take this is x2. Now the length of the string x1 plus x2 plus again this is x2 plus x3 is constant. So I can write x1 plus x2 plus x2 twice x2 plus x3 is equal to constant. I am not taking this wrapped part. I differentiate this. with time. Constant differentiation is 0. Again I differentiate this with time. So this is called constraint theory, in which we need to find out the relationship between the velocities and accelerations of the connected objects through multiple strings. Now this is a problem. If I say velocity of b at certain instant is 2 meter per second in downward direction, then find velocity of a at that instant. So let us solve this problem through constraint theory. Now anyway, this part of the string always remain constant, as well as the wrapped part, this part. But if you look carefully, if I take here, this part always remains constant, this part always remains constant, this part always remains constant. So I need not to take from here, I will take the displacement from here. Let us say this is displacement xb. Let us say this is displacement xa. Now this part, wrapped part, this part, and this part always remains constant. So I will not include this constant part while taking the length of this string by the means of displacements of each blocks. Now if I look carefully, this is xb, this part is again remaining constant, this is also xb, this is also xb. So total there are 3 xb's, and this is one is xa and this is one is xa. So I directly write 2xa plus 3xb is equals to length of the string constant. Now I differentiate this, 2va plus 3vb is equal to 0. I need to find out velocity of a. So 2va is equal to minus 3vb. So va equals to minus 3 by 2 vb. Now it is minus 3 by 2 into vb is nothing but, here I take 2 meter per second in downward direction. So while taking the velocities, you must be very much concerned in taking the directions. So downward I take it to be negative. So vb is minus 2. So this cancels, minus minus plus. So this is 3 meter per second upward direction. Now here this is a pulley which is moving with Vp, and this A and B are also accelerating. So anyway, I can write here velocity of A with respect to P will be minus velocity of B with respect to P. As A will be moving, B will be moving down with respect to this pulley. So vector signs, I will take relative means so I can write here so here I can write velocity of pulley is VA plus VB whole divided by 2. Now remember, here all the velocities has to be substituted with proper signs. If you take upward as positive, downward is negative. You have to substitute with proper signs. This is a pulley given, all the velocities are given. We need to find out velocity of A and velocity of B. Velocity of P2 is given. Now as A is moving upward, P2 will move downward. I am talking about P2. So when P2 is given as 10 meter per second downward, so velocity of A I can write directly minus velocity of P2. P2 is given 10, so minus of minus 10. That becomes 10 meter per second upward. We got it. Now we will have velocity of B with respect to P2 is equal to minus velocity of C with respect to P2, which we described just now. I directly write velocity of P2 is equal to velocity of B plus velocity of C divided by 2. Now here I can write, I need to find out velocity of B. I can write here velocity of B with respect to P2 is equal to minus, or I can write here equals to velocity of B minus velocity of P2, and velocity of C with respect to P2 is equal to velocity of C minus velocity of P2. And I have already taken velocity of P2 is nothing but given as downward direction 10 meter per second, or here I can directly substitute instead of this. Velocity of P2 is given as 10 meter, so minus 10 is equal to VB plus VC. VC is given 2 by 2. I can write directly minus 20 equals to VB plus 2, or I can write VB equals to minus 22 meter per second, or VB is equal to 22 meter per second downward direction. I get this answer in this way. Now let us have there is another method we will try to discuss, that is called virtual method, where we will find the relationship of acceleration very simple way. I take here a virtual method says that work done by tensile force, total work done by tensile force in a system is 0. So let us say this is T1, this is also T1, this is also T1. Let us say this is T2. I can say this one is moving downward, this is moving upward. So let the here displacement be x1 at any instant, here the displacement is x2. So total work done by tensile force for a system is 0. So if I take this block, the displacement is downward, tensile force is upward, so work done is negative. In this case, tension is upward, displacement is upward, so displacement the work done is positive. So I can write T2 into x2 is equal to, I can write T1 minus T1 into x1 must be equals to 0, or I can write T2 x2 is equal to T1 x1. Now for this pulley, I take these pulleys are massless, so I can write T2 minus twice T1 is equal to 0, or T2 is equal to 2T1. So I can write here 2T1 into x2 is equal to T1 into x1, cancels out. So x1 becomes twice x2, or a1 equals to twice a2. Relationship between the accelerations by virtual method. This is one of the beautiful problems we have. This is system 2 kg block, 3 kg block. System is released from rest. After 2 seconds, the 3 kg block is hold for a moment and then released. Find the time after which the string becomes taut again. Now, when the system is released, acceleration of the system we can easily find, that is A equals to 3g minus 2g divided by 3 plus 2, 5. So this is g by 5, or 10 by 5, 2 meter per second square. Now after 2 seconds, that means 2 kg block will be moving in the upward direction, 3 kg block will be moving in the downward direction. So after 2 seconds, velocity of 2 kg block I will write velocity of 2 kg block as well as velocity of 3 kg block is nothing but is 0 plus 80. A is 2 into after 2 seconds 2, that is 4 meter per second. That means 2 kg block will be moving with 4 meter per second upward direction, 3 kg block will be moving in the downward direction, but 3 kg block is hold for a moment. That means velocity of 3 kg block becomes 0, but 2 kg block is still moving upward direction. But when I am holding this 3 kg block, the tensile force becomes 0 because the string is loose now, I am holding it. But 2 kg block, due to inertia of motion, that like for Newton's first law, 2 kg block is still moving in the upward direction. Now 3 kg block is at rest, then suddenly I leave this 3 kg block. Now after some time, now when I leave this 3 kg block, the 3 kg block falls down with an acceleration due to gravity, not with this acceleration, because tensile force has already become 0. That means this acceleration will not become effective, but velocity of 2 kg block is 4 meter per second. Now let us say let the time to be t dash at which this string becomes tight. Now 3 kg block is falling freely and 2 kg block is moving with a velocity, initial velocity 4 meter per second, but both these blocks are under the influence of acceleration due to gravity, not with this acceleration. And so at time t dash, the displacement when the string becomes taut, whatever the displacement this 3 kg block will move, 2 kg block also will move the same displacement. So I write let at time t dash the string becomes taut, and in this time t dash displacement of 3 kg block is equal to displacement of 2 kg block, but 3 kg falls freely and 2 kg block is moving with initial velocity. (4 meter per second) upward. So let us calculate the time. So 3 kg block falls freely, so displacement of 3 kg block is equal to half gt dash square, and displacement of 2 kg block, it is moving with initial velocity ut dash minus half gt dash square, and here u is 4 meter per second as we calculated. Later on we will substitute. So this S of 2 kg block is equal to S of 3 kg block. So ut dash minus half g t dash square is equal to half g t dash square. That implies g t dash square is equal to ut dash, cancels out. So t dash is u by g. You have got earlier 4 by 10. So after 0.4 seconds, both the string will become taut again. Now this is a problem which will explain you about the superposition of all the forces, and which will explain that force is a vector quantity and how to solve through vectors. The question is 5 persons A, B, C, D are pulling a cart of mass 100 kg on a smooth surface, and cart is moving with acceleration 3 meter per second square in east direction. When person A stops pulling, it moves with, that means the cart moves with an acceleration 1 meter per second square in west direction. When B stops pulling, it moves with an acceleration 24 meter per second square in north direction. That means when B stops pulling means A is still continuing, and find magnitude of acceleration of cart when A and B pull the cart keeping their direction same as old direction. Now initially when these 5 persons are pulling, so let us say let F net be the force when A, B, C, D, E are pulling the cart. So I write vectorically F net equals to mass of is 100 kg and it is moving in 3 meter per second square in east direction. So I take east direction to be I cap, west direction as minus I cap, north direction as plus j cap, south direction as minus j cap. Now when A stops pulling, that means I can write F net minus FA. That becomes when A stops pulling, it moves with an acceleration 1 meter per second, that means 100 kg in west direction, so minus 1 I cap. And when B stops pulling, so I write F net, here I write when B stops pulling F net minus FB 100 into in north direction 24 j cap. My intention is to find out FA vector plus FB vector is how much. Now I can substitute here. F net is 300 I cap, this is 300 I cap, this is minus 100 I cap, this is 2400 j cap. So this is equation 1, equation 2, equation 3. So here I will substitute here in equation 2. Equation 2 reduces to like F net is 300 I cap minus FA is equal to minus 100 I cap. So this becomes that implies FA equals to 300 I cap, this 100 I cap comes over here, 400 I cap. Now equation 3 reduces to, again I will write 300 I cap minus FB equals to 2400 j cap. So this becomes, that implies FB equals to 300 I cap plus 300 I cap minus 2400 j cap. So FA plus FB I will do. $400 I cap plus 300 I cap minus 24 j cap. This becomes 700 I cap minus 2400 j cap. Now you can find out FA plus FB, that becomes 700 square plus 2400 square, and you can find out the acceleration A plus AB is 1 by 100 into 700 square. And I think this answer will come as 25.